have to find the center of mass of a sheet, thin sheet, which has the dimensions like this. This thin sheet is lying in the XY plane, and this is, you can take it as a combination of two pieces. One is 4 meter by 4 meter, this is 2 meter by 2 meter. All the things they are same, that is its density is same, its thickness is same. We are interested, that is where the center of mass of this system, that is this 4 by 4 sheet and this 2 by 2 sheet, which are connected together, where is the center of mass of this system. So once again over here we see that is there are two symmetrical figures. One is over here, the other is over here. So its center of mass will lie on the symmetrical axis. We have a number of symmetrical axes. This is symmetrical axis about, this is also symmetrical axis. This is symmetrical about this axis also. This is symmetrical about this axis also. It is symmetrical about diagonals also. Same thing goes for that. So its center of mass is over here. The coordinates, so total is 4. So this is going to be 2, 2. They are going to be coordinates of this. Its center of mass will lie over here. What are the coordinates of this? This is, if this is 2, so from here to here is 1 meter, but from here to here this is 4 plus 1, so it is 5, this is 2, so half is 1. So coordinates, they are 5, 1. They are the coordinates of center of mass of this sheet, and this is 2, 2. They are coordinates of center of mass of this sheet. Rest is simple. Once again we can say that is XCM. Suppose this mass is M1 and this mass is M2. Of this piece is M2 and of this piece is M1. So once again, as we did earlier, so it is going to be M1 into X1 plus M2 into X2 over M1 plus M2. Or let's say for a time being we simply say that is M1 into X1 plus M2 into X2 over M1 plus M2, because we intend to arrive to a general formula. So that's why instead of directly taking the numerical value, let's take the general values as X1 and X2. So mass, we know mass is equal to volume into density. So we know mass is equal to volume into density. And what is volume? Volume is area into height. So the mass becomes area into height, volume into density. That's right. This height, we can also call it thickness also. That is area into thickness into density. We can call it like this. So over here, thickness and density of this whole material, whole sheet is same. That is, thickness is same and density, it is made from the same material, so density is also same. So if you put it over here, that is instead of M1, so we can call it as area into thickness, this volume into density. It comes out to mass into X1 plus M2. M2 is area into thickness, that it makes volume into density, makes mass into X2 over, once again, mass of 1, that is area of this A1 into thickness into density, mass of 1 plus A2 T rho. We see over here that is T and rho, they can be taken out and they can be cancelled. So this comes out to a formula, comes out to be A1 X1 plus A2 X2 over A1 plus A2. So we get the formula. Like if the mass is distributed over 3 dimensions, we can take this formula as XCM or X bar is equal to integral of X dm over integral dm. If the mass is distributed over area, this formula takes the form we see over here, that is X bar, it takes the form X dA over integral dA. That is X1 A1 plus X2 A2 plus X3 A3 over A1 plus A2 plus A3. That is same thing, essence remains same, essence remains same. Similarly, if the mass is distributed over length only, so then over there for length, it comes out to be X into dl over integral dl. As the pattern remains same, as over here this thing has cancelled. Similarly, if it is distributed over length, the rest of things they will get cancelled and will take the form X dl over integral dl. So this formula is when the mass is distributed only over length only. Over here, when the mass is distributed over area, so this is this formula, and this is when obviously when the mass is distributed over volume, or for any case you can use this, because these two formula they also have come from this formula only, so this is always applicable.